Here's a futures problem you can try and see if you get the answer that I get. This is GE. They use a large amount of copper, making appliances, railroad locomotive engines, all sorts of things. And if they wanted to hedge, let's just assume they're going to use 4,000 contracts and a copper future, and the future's trading at $3 per pound. And spot prices today are $3.02, and by the end of the contract they fall to $2.95. So the first question I have is just for a copper user: do they hedge by being long or short the future? And I'll wait a few seconds and then reveal the answer. Long. Since they're a buyer of the asset later, they are buyers of futures today as a hedge. They want to profit from price gains on the hedge to offset the cost of price rises in copper. Let's try the hedge payoff, and you may need a calculator or a piece of scratch paper. The hedge payoff formula for that, if you recall, is number of contracts times contract size times profit or loss. $5 million loss, contract size 25,000 pounds, 5 cents per pound loss. The reason it's a loss is that you're long the future price, or spot prices fell from 302 to 295. The futures price at expiration is 295. So your future that you were long went from $3, where you entered it at the beginning, to 295. 5 cent loss times the 25,000 pounds times the 4,000 contracts is a $5 million loss. What about the impact of this hedge on the effective price? Well, the effective price, if you recall our earlier examples, $3 that we locked in with the future. And how did we get to that? We did that by buying at 295 spot. However, we lost money on the hedge. We lost 5 cents, raising our overall price of purchasing copper, both in the product market as well as in the derivative hedge market. Our overall price is $295 plus 5, or $3, which is what we locked in with the future.